This question is asking us to determine if the triangles are similar or not. And if they are similar, we have to write why they're similar. So we're going to pick from three different theories. One that could work would be side, side, side. Another is angle, angle. And then the third one will be side, angle, side. Now in part A, I'm going to start off by calling out a triangle. And that's going to be triangle VML. I'm going to write that is similar to another triangle. Now I have to be careful when I call out all my corners of the triangle here. On my left triangle, I started with V, right? And that's going to be the shared vertex point of both of these triangles. And then from V, I go across 14 here. That's the longer of the two sides. So then for the triangle on my right, I'm going to start from V and I'm going to go across the longer of the two sides here. You can see that 49 is bigger than 28. So I'm going to go from V to T, and then the last part is going to be U. So I don't know if these two triangles are similar or not, but we want to prove it. Now here are the three potential theorems that we could use: side, 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 angle, angle, and side, angle, side. And we're not given three sides here. We're only given 8 and 14 for this triangle, and then 28 and 49 for this triangle, and there's no way to figure out that third triangle, the third side in each of those triangles. So I'm not going to be able to use side, side, side. As far as angle, angle goes, well, I'm given vertical angles right here. This right here and this one right here are going to be vertical angles, so they're congruent, but I don't know what angle M is, or I don't know what angle L is, so there's no way I'm going to be able to use angle, angle. However, if I look at my triangles, I do have a side and then an angle that's congruent, and then another side. So I'm going to try to prove side, angle, side. Now, they might be similar, they might not be. We have to check to see if these corresponding sides are in proportion. So the first side I'm going to use is VM here, and that's going to be 14. So I have 14, and we divide that by the corresponding side of the right triangle. So VM matches with VT, which is going to be this amount, which is 49. That's going to be set equal to my other corresponding sides. So that's going to be 8 divided by 28. So 8 divided by 28. Now, is this true? Will this equation work? Well, if I do 14 divided by 49 in my calculator, I get 0.2857, and that's going to be a rounded answer. That's going to be this fraction there. And then 8 divided by 28, looks like I get 0.2857. Again, this one's rounded as well. So we're going to assume that these two fractions are equal to each other. That means that the corresponding sides are in proportion. So we could call these two triangles similar by side, angle, side. In part B, I'm going to do the same thing. I'm going to call out two triangles. The first triangle that I use is going to be triangle KBC. So I write KBC here is similar to another triangle, and it's going to be this big one. It's going to be KLM. KLM. And that's a little bit easier to see how the triangles match up. Now, are these going to be similar or not? I'm going to bring up my three theorems. And as you can see, I have a bunch of sides, but I do not have LM, and I also do not have BC. So let's not try to use side, side, side. If we look a little bit closer into this situation, we do see that we have a small triangle right there and a bigger one. And that bigger one is right here. And whenever you have this situation, you could look to see if there's an angle shared. And in this case, there is an angle shared. It's this one right here. It's going to be angle K, or we could say BKC. So that's one angle that's going to be congruent and be corresponding angles. So I'm going to ditch angle, angle. I'm not going to look for another one. And I'm just going to try to prove side, angle, side again. And because we have the angle, we want to just figure out if the sides are in proportion or not. So this side right here, KB, that's going to be 16. We want to divide that by this big long side here. It's going to be KL. That's what this side is right here. So that's going to be 88. We'll figure out what that is. And the other side is going to be KC. That's KC. And that matches up with this longer side, which is going to be KM. Right there, KM. Remember that the letters all match up accordingly. So K and B match up with K and L, and then KC match up with KM. Order is very important when you write this similarity statement. Okay, back to what we were doing. I said that KC was 25, so I'm going to write that down, divided by KM. So we're going to have to add these two parts right here. That's going to be 132. Now, we want to see if this equation or this proportion is true. Okay, so I take 16 and I divide it by 88. That's going to be 0.18 in repeating. Okay, that's going to be this fraction, an estimation. And then I do 25 over 132. That's going to be 0.1893, and I believe the 93 is repeating, so that's going to be that. Now, are these two equal? Well, close, but they're definitely not equal. So these corresponding sides are not in proportion. That means that these triangles are not similar. So yeah, we just don't have similarity here. And all this math here proving that they're not similar, that would fit the whole, like, if they're not similar, explain why. That would work for that. And finally, part C, we have a situation that's really similar to part B. It looks like we have a big triangle here, FDE, and then we have a little triangle inside it, FSR. So I'm going to set up that similarity statement. There it is. Now, I'm going to show you the small triangle here. You got triangle FSR, and then the big triangle is going to be FDE right there. And remember, in these situations, we always have an angle that's being shared. So angle F is going to be a shared angle. Now, we don't have any other angles that we're going to use, so it's not going to be angle. And do we have all the sides? Well, yeah, it looks like we have all the sides. This side right here is 44. This is going to be 121. We have this segment right here, RE. That's going to be 91. And if we wanted to, we could calculate FR, because all we have to do is take 143 and subtract 91 from it, and that would give us FR. And we could do the same thing down here. This entire side is 88. So if you subtract SD, which is 56, you're going to get this part right here. There's a math that shows all that. Now, I believe I could use a side angle side as well. We have 52 and then an angle and then 32, and then we could do 143 an angle and then 88. That would potentially be side angle side, but because we've done those already, let's try a side. So that means we're going to match up FD and FS. So FD was 88, and we're going to divide that by FS, which was 32. We'll get an answer. Then we're going to take this bottom side here. That's going to be DE. That was 121. And divide that by the smaller one, which is SR, it looks like. So SR is 44. We're going to get an answer there. And then we want to use this right, or this top side, I guess you'd say. That's going to be side FE. And from F to E, it looks like we're at 143. So I do 143 divided by FR. That's going to be the smaller side here, which is 52. Okay, now all three of these sets of corresponding sides have to have the same number, and if they are, then we're going to have similar triangles. So 88 divided by 32 is going to be 2.75. 121 divided by 44 is going to be 2.75. So far we're good, but we need all three of them to be the same. And if I do 143 divided by 52, Yes, I do get 2.75, so all three are the same. That means that these two are going to be similar triangles, and we proved it using side, side, side. Now, you could have proved it using side, angle, side as well. In that case, you would have taken 88 along with this angle right here, and then 143. That would have been the side, angle, side, and match that up to be 32, which is the side that corresponds with 88, and that's what we did right here. Got 2.75. And then this angle, which was corresponding to angle F, and then 52, which corresponds to this side. And we did that down here, which we saw was also in proportion with the other pair of corresponding sides. So if we did it that way, we would have proved it using side, angle, side. So either one of them would